Okay, good morning, everybody. Welcome to the K2 Systems webinar. Hopefully everyone can hear and see this okay. Hopefully you've had a chance to get yourself familiar with the GoToWebinar setup. You'll see there's the opportunity to ask questions of us in the question window. These are questions that you would type and we would answer by typing them. There's also the option to put up your hand, so to speak, and then I could turn your microphone on and you could ask a question out loud. Okay, we're still receiving a few more attendees, but we will make a start. In a moment, I will just put a question up on the screen for you all to answer, so that we can tailor this webinar accordingly. And over the hour, we will mostly look at planning flat roof projects and planning trapezoidal metal sheet projects. But if there's anything in particular you want to know, please do ask a question. We'll be happy to help. Okay. Okay, the results are in. It's a pretty much 50-50 split, with the people who do use K2 Base regularly just edging it over the people who don't use it regularly. So this webinar is a bit of an introduction to Base. So for the regular users, you know, if there's more detailed things that you want to know, do ask us questions, because as well as me, there's a couple of other people here as moderators who can answer your questions. And then we do also plan some more in-depth webinars in the coming weeks. So something for everybody, hopefully. So thank you for answering that question. I believe we will make a start. So hopefully everybody can see the base start screen here. Okay, so this is the start screen for Base. You'll see I'm logged in as a webinar moderator. You can use a reduced function version of the software without a login, but we recommend that you do get a login, which is very simple. You'll see there's just a sign up button here, and we will process that application immediately. So getting an account is free and it's easy, so we recommend it. And then once you're logged in, you'll see up here your username. This is the way the screen is set out. So we have here the 4 boxes: new project, open project, app project, and help. Now, app project is something we'll leave for future webinars. We've got a very nice, very clever smartphone app, which can interface with this software. There's more information on that on our YouTube channel and on our website, and there'll be webinars on that subject. We also have these up in the top left screen, the same: new project, open project, save project, download project file, help, and Sherpa. Now, Sherpa, just quickly, is an online help chat, which also works over the WhatsApp platform. Again, we won't look at that today, but that's useful to know. As well, this help section is full of lots of useful subjects, some with videos, some with text, as you'll see here. So to get yourself familiar with the software, it's a very good thing to work through this help section. Okay, so we will start by planning a flat roof project. You'll see here we have the option to toggle expert mode You can work in either. You will still get a fully calculated project, but I suggest for the people who don't use K2 Base regularly to plan not in expert mode, and then for the more regular users to use expert mode. There's also a function here which is very useful for new users, which is walk me through, which will take you on a step-by-step sort of tour through planning a project. But of course, that's what I'm here to do today, so we don't need to look at that. Right. So you're logged in and you'll create a new project. And then this will be the start screen. I believe the default country that appears when you start will be linked to your user profile. So this user profile has Germany as the default country. You can click around the screen and change where you want to plan your project. You'll see also that the design method here changes for the country that you've selected. So we've got a large database within the software of the relevant Euro codes. So you'd always be planning according to the correct Euro code for the country. And any that aren't in there yet, such as Norway, will just come up as Euro code. And then you can see here is a list of all the available ones. So we'll plan first a project in Germany. So now the software uses the Google imagery, as you can see down here in the bottom right. Got the option to work with satellite imagery, with location tags, which are called hybrid, which you see gets more detail as you zoom in, or you can work with the Google roadmap. Now, when you're working with an existing building, it's a very useful tool. For example, if we have a look here at the K2 Systems headquarters, you can see there's some nice buildings here that we could plan a project on. I believe that is K2 here, but there is a nice roof that we will use for this webinar up here. So I could enter the address manually for this roof, or because I found it here, I can double click on it and the address autofills here. Now I can put in a name for my project, and it's good to name all of your projects because on your user profile, you'll have all of your saved projects. So by putting in a project name, as well as your customer name and contact, it's easy to keep everything looking neat and tidy and find all your previous projects. So for this one, we could just call it webinar 16th April. The author automatically fills to your user profile name, but if you wanted to change that, you can. And then in here, you would put your customer name and your contact name. And if you wanted to, you could use tags. For example, if you plan lots of projects that are linked to perhaps a community energy cooperative that might be called whatever, co-op, then you could tag all of these projects with that same tag just to help you find them all easily at a later date. So once we've completed this section, you'll see we have a timeline up here: start, project, roof, design, loads. And we can now access the roof section. So we're working sequentially from left to right. And you can see the sections that are in bold can be accessed, and the ones that are in grey cannot yet, because we need to work as a sequence from left to right. So now we access roof. We're going to draw a roof. So this window pane on the left is where we work, and then the window pane on the right is where we see. So you see the options here again. We can access this button and not yet these buttons. And by holding your cursor over the buttons, you can see what each one is a command for. So here, add new roof, we click the button, then these are our options. So we want to plan a flat roof. Now we can plan two roof shapes for flat roofs, polygon or rectangle. Rectangle is simple four-sided shape. Polygon is a roof shape of infinite sides that you can draw accordingly. So to keep things simple, we'll go rectangle. And then see roof covering, we only have one option because flat roofs really only have this option. But you can see for the software, we can also plan tile roofs, trapezoidal roofs, seam metal roofs, corrugated roofs. So we select flat roof, rectangle, and even, and then we add. Now, I've received lots of phone calls from people who get to this stage and say, I've added a roof, but it's not there. This is because now is the time when you draw the roof, and you'll see the mouse cursor has become a cross. So we want to click on each corner of the roof and draw out our outline. Now you see here the dimensions of feet, and up here we can toggle between metric and imperial. We'll use metric. Now this will give you a fairly accurate idea of the actual roof dimensions. But if you have been to site and you have actually measured this roof, then you can change these either by clicking and dragging, or you can switch to 2D view up here on the right. You click there, and then you're working in a simpler work window. And here you can manually change the dimensions. So you click on the number and then type what you would like it to be. That way, if you know the exact measurements, you can make sure you're planning with precision. And another regular question we get from people, they say, the building is not built yet, so how do I plan on K2 Base? Well, you can still find the approximate location and make sure you're working with the right local codes. But then by working in 2D view, you can ignore all of the Google map imagery and just work with the roof shape as you see here. So it doesn't matter if the roof is not on Google imagery yet, if it's a building that hasn't been built yet. So you can work in map view or 2D view, and you can constantly toggle between satellite, hybrid, and road map. Now you see here in the left-hand side, some more options are available to us now. And there are some boxes that have come up in red as a reminder that these are important things that need entering. So we'll start. Building height is self-explanatory, but for a lot of these parameters, you'll see these question marks. If you click on the question mark, you'll get a visual clue as to what you're doing. So you'll see there what building height is considered as for a pitched roof and for a flat roof. Now for pitched roof, some people might measure the height at the eaves or the gutter, but what we want is the height at the highest point of the roof, as you can see there. So we enter our building height. Now you see here it's got 0 meters as default. So when you type in your building height, you just put a numerical value. You don't need to put M for meters. So here we have a 10-meter building. Now roof pitch, presumably we would expect something like 1 or 2 degree pitch. So let's say 1. Now roof pitch orientation, as we see here, we have the same parameter if it's a pitched or a flat roof. And for this, we want to know which way the roof does slope. So which direction the water would run off. And we can change this with the plus and the minus. And you'll see on the main screen that the arrow points to a different side of the roof each time. So the arrow dictates which way the slope runs on the roof. Next we have roof material. Now our options: single ply membrane, bitumen, green roof and gravel. Now the reason we ask is because the thermal expansion parameters and the maximum rail lengths are different for the first two than they are for the second two. That is, we allow larger array blocks and larger rail lengths on green roofs and gravel roofs than we do for single ply membrane roofs and bitumen roofs. This is because of the concept of caterpillaring. So how a system has the potential to move slowly over time. And obviously we want to plan our system so that this doesn't happen. The problem is most apparent with these two roofs, single ply membrane and bitumen. And the problem is less so with green roofs and gravel. So we would select what we have. If we're doing a desktop survey, we might want to make an assumption of what this is by looking at the satellite imagery. And we might think this is a single ply membrane, for example. Then we have parapet wall height. So this is, I think, will obviously be called different things in different languages. I think it's Attica in German. So, but parapet wall height is the height of the small wall that elevates above the flat roof around the perimeter of the roof. Now, some people think a parapet roof is a good thing because there's the added safety that the system cannot fall off the roof. This is true, but parapet roofs can cause wind turbulence. So we need to know the height of the parapet wall, because the modules that sit near the parapet wall may be subject to extra wind turbulence and may need extra ballast. So we can put in our value here, say 0.3 meters. And next we have a friction coefficient. Now, friction coefficient, as it says here, interaction between the roof cladding and the building protection mat of the mounting system. A lower friction coefficient requires more ballast. So, or in other words, if the roof is slippery, you need more ballast. If the roof has good grip underfoot, you need less ballast. Now, how can you measure this? Well, we supply the friction coefficient test kits. It's a very simple test. We've got videos showing how you use it, but essentially you have a calibrated scale and a 1 kilogram weight, and then you measure the force required to move that weight across the roof with the building protection mat between the weight and the roof. And this helps us determine the friction coefficient. Now, the friction coefficient is generally higher for bitumen roofs as they have the small stones, and often lower for single ply membrane roofs, and then higher still for concrete, gravel and green roofs. But the only way to really know is to do this test, and it's very quick, very simple. It does mean that you would need to get on the roof. So if you're doing a desktop survey before visiting the site, then you may like to ask your K2 or distributor contact for some example friction coefficients for different roof coverings. Now we're planning single ply membranes, so we might expect something like 0.5. Now we can plan in obstructions. We don't have to plan in obstructions. You can see that because we've filled out all of the relevant information, we can access the design tab. But the obstructions section is quite useful. So again, we're going to draw our obstructions the same as we drew the roof. We can draw polygon obstructions, rectangle obstructions, and line obstructions. So we might draw some rectangle obstructions. And as with roofs, I didn't mention this, but with roofs and obstacles, we can name them. So we might like to call this vent pipe 1. And perhaps we know that it's not that big. We can change our dimensions in 2D view. And we can also change the height of our obstruction if we want to go into that detail, which is useful because the software will show you the extent of the shading caused by that obstacle. So you know that perhaps you don't want to plan your modules right up close to this obstacle because you can see the dark area where you have the shading from the pipe. Now you can see this roof, there are a few different obstacles, so we could quickly replicate each one and move these into the correct locations like this. We can also resize them if need be. And then we can delete them, or we can draw new obstructions. We could draw a polygon obstruction, like that, for example. Now we might like to consider that this building here casts a shadow, which is obvious here. So perhaps we could draw in an obstruction. There's no physical obstruction, but maybe we want to avoid this area because of the shadow from this building. And then here we have remarks. Not necessary, but for each project you plan, you can produce a report which you can give to your client or to your structural engineer or to anybody. So in here, you might put in your remarks, for example, this is a first stage or a provisional report. All items subject to confirmation, something like that. Okay, so we've planned our roof. Now we want to plan our array. So we move to the design section. Now, first we need to select our module. Now we can access this large module database by searching here on the module name, or maybe quicker, we just enter the values manually if we know what they are. So we have our module details. We now want to plan our module array. So we click onto module arrays, and you'll see here that the plus button, add new module field, is available. We also have here this A and M, which we can click at this point. So orientate modules automatically, orientate modules manually. So what this means, we have automatic as default, and this refers to the green line that you see here. So if we were to plan an S-dome project with single modules south-facing, then the back edge of the modules will be parallel with this green line. If, however, we wanted to plan them to face a different direction, for whatever reason, we would click this button here and choose the roof edge that we wanted to orientate the modules against, or we can go back to automatic. So now we plan our array. Now here we would select our system. We've got the system names and we've got images of each of them. So I think today we'll plan our Estome V10 degree system. So select that, and you can see the insulation type automatically goes to elevated because it is an elevated system, and orientation automatically goes to landscape. So our available options here are to click complete roof and module field. So if we were to click complete roof, which I'll demonstrate, the whole roof will fill with modules. And if we were to have selected module field, then the same as we drew the roof and the same as we drew the obstacles, we now just draw our module field by clicking and dragging an area as shown here. Now you can resize this. If we were to place this over the obstacle, you see that the modules are deleted where the obstacle is. Same with over here. And again, we can work in 2D view or in the map view. So we have a look at what 2D view looks like. This is our array. We've got 9 rows of 15. We can manually change that by overriding these values. So 9 rows of 12. Now back to this left-hand window. The row spacing will be automatically calculated according to the slope on the roof, the pitch of the system, the dimensions of the module, and the location of the project. But if you want, you can override this, type in your own value. You can also change the system as well. We did select this one, but if you wanted to, for example, use a 15 degree, then you can change it here, or even switch to a D-dome system, a double-sided east-west. But we'll assume that this is our array. Next, we can select the color of the module clamp, silver or black, just to make sure the correct item is in our bill of materials. And then we're on to our thermal gap section, which perhaps gets the most questions of any part of this planning process. So as it says here, thermal gaps, the breaks between module rows and columns to account for expansion of the material from heating. So for those that don't know, we will always plan in thermal gaps to large arrays because array sizes need to be kept within certain limits so as the material can thermally expand safely without causing any long-term issues with your project, such as caterpillaring, the walking that we mentioned before. So we have our defaults here, and they're set to the maximum parameters, which is 10 modules, maximum 10 rows, and then maximum 9 modules in the row. So if we wanted to change this, we can override that again, put in 5. They can see here that we have a thermal gap where the white line is. So we've got, because we entered thermal gap every 5 modules, we count 5 from the front. So 1, 2, 3, 4, 5. Here's our thermal gap, and then there's the other 4. Now, the other way to use thermal gaps is to plan in maintenance walkways. So it's not always an issue with Estome because you have the gaps between the rows. But if, for example, you wanted to plan in enough space to walk after every 5 modules for maintenance, then you could put a thermal gap every 5 modules, width of 1 meter, and there's your maintenance walkway. So that's quite useful. And then down here, we just have a reminder of how many modules we've planned and what the output power is. So now we have the option to move into loads. We can see here again, here's the satellite image. So you can take screenshots of this if need be to send to your customer. It's quite nice imagery, how it might look. Anyway, so loads. Now, when working in projects in Germany and some other countries, got a very nice function where the wind and snow loads are determined automatically, because the software knows exactly where we're planning the project. So we can click this button and we have our peak velocity pressure for the wind load, 0.45 kilonewtons per meter squared, and our snow load on ground level of 1.28 kilonewtons per meter squared. Now, if we wanted to, we could enter this manually, or in ways that you might be more used to with the Eurocode, by entering the input parameters according to the terrain categories. Or if you know exactly what loads you should work with, for example, if a structural engineer has determined the loads and asked you to plan the project accordingly, then you can enter them manually in here. So we've determined our loads. We can now click onto results. And you'll see here we have our ballast plan, and we have our numerical values for all of the ballast. Now, it's worth noting here, because of our thermal breaks, we've got 4 different array sizes. So we've got our 5 rows of 9, our 3 rows of 9, 3 rows of 3, and 5 rows of 3. Now, the general rule is the larger the array block, or the more modules interconnected within an array block, means the less ballast required per module. So we'll see this, our largest array block, here we have, say, 5 kilograms, 5.5 kilograms, 3 kilograms over here. And our smallest array block, 30.5, 15.5. So you'll see it makes sense to plan large array blocks, because then you will need less ballast and it will cost you less to install the system. This was all determined through our wind tunnel testing at the Wind Tunnel Institute. So it's all very trustworthy information. So you'll see at this point, then perhaps we want to change our thermal breaks so as to balance out the ballast. So we could jump back to design, find our thermal gaps. Now, instead of having, don't know what that error was, we'll ignore that. So instead of having a gap after 9 modules, perhaps we'll have it after 6. You can see that the array is more balanced, and this one, instead of after 5, maybe we'll have 4. We jump back to results, and you find that the ballast is more balanced. So each array is comparable now, which perhaps is good for the structural engineer, so that the loads aren't concentrated on one part of the roof. Now, system type. For the Dome V systems, we've got generation 1 and generation 2. Simply put, generation 2 supersedes generation 1. Other than that, there's not too much to know about it. Really, your selection should be based on availability. So it's a case of speaking to your K2 contact or your distributor. Now, there's the option here to use corner bracing. Now, corner bracing is a feature that works best with D-Dome systems, not S-Dome systems. So my recommendation, don't worry for S-Dome systems, but for D-Dome, select corner bracing and compare your ballast values, because by using corner bracing, which is to use additional components to stiffen the array, the ballast required can be reduced quite drastically. So it's a very useful feature. Now here we have ballast capacities for the components. It's worth, unless you know otherwise, then just leave these as the defaults. This is the suggested amounts of ballast that you can get on the different ballast trays for the system. So the different ballast trays for this system is the upstand and the rail, because the rail is a ballast carrier. Then we have speed porters and we have porters. So you'll see that the upstand and the rail can take about 20 kilos because of limitations on space. The speed porters about 40, and then the porters about 120. Now we'll just jump down here. You see the ballast can be displayed in kilograms or in numbers of stones, which is useful. So if you know what ballast you would use, for example, if you use a 3 kilogram brick, you could put 3. And then on our ballast plan, instead of a value in kilograms, it just tells us how many bricks. So 7 bricks, 6 bricks, 5 bricks, 3 bricks. It's very useful. Or we could change this 5 kilos, and we'll see these numbers change. So this makes a very nice simple ballast plan for the actual installation work. Now here, these are all probably worthy of more in-depth webinars, so we won't worry about them too much. But these are optional extras we have for lightning protection, for earthing, for cable management, and for mounting of optimizers. And essentially, if you tick them, then you'll have extra components in your bill of materials. So here we can also check loads on modules. Now, module manufacturers will tell you the maximum load that is permissible for the module for the clamping method. Now, these dome systems will have the module clamped on the short side in the corners. On our website, you'll see a list of approved modules where the module manufacturer has explicitly okayed this method, and they will tell you the maximum load that can be planned on these modules. It's usually 2,400 pascals. So you can see here we have 1,953. So we're within permissible limits for the module. And you can see here as well, verification system utilization. So this is whether we are within the limits of the structural capacity of the system, and we are. We get a nice green tick, and all our values are below 100%. So we can jump back and make changes at any point, or we can continue on to our summary. And here we have our bill of materials, and we have a summary of what we've planned. We've got roof 1, S-Dome V 10-degree system, our 250 watt modules that we didn't give a name to, 96 of them, 24 kilowatt peak output power. And here we can produce our various output documents. So we can produce a project report with as many of these sections or as little of these sections as we like. We'll just tick the boxes for what we want. So project data, assembly plan, ballast plan, results, structural analysis, horizontal and vertical loads, bill of materials. And by clicking generate, you'll download a PDF document, which I'll show you quickly. Now this is just the project data, so it's a short document. But this way we can produce any combination of reports, save them as PDFs. So for example, the installers might just want assembly plan and ballast plan, Structural engineer might want the project data and the structural analysis and the horizontal and vertical loads. So you've got the different options. We can also export a ballast plan and a bill of materials as an Excel file. And then we have here K2 Plus inverter design. Now we've got functionality, we've got compatibility with Fronius SMA and SolarEdge designers. So if you work in K2 Base, you can export your design and bring it into those platforms as your starting point to save you duplicating your work. So that's the subject of other webinars. It's very useful if you work with those inverter manufacturers. And then here is, I mentioned about our K2 app. So this is how you would work and correspond with the K2 app. Okay, so that's a flat roof project that we've planned. I see there's a few questions popping in that my colleagues are dealing with. But if you've got any questions, do feel free to ask. You can type them into the questions box, or you can raise your hand and speak a question. Now we could plan a trapezoidal roof. So we might want to plan a trapezoidal roof as part of the same project. So for example, if we have two roofs here, we can just add another roof onto our project, a flat roof or a pitched roof. For example, assuming this was a trapezoidal roof, we draw this on here, and then we have roof 1 and roof 2 within the same project. Or we can go back and plan a whole new project for our trapezoidal. So we'll do that so we can show you some other features. Now for this one, I think we'll plan at our premises in the UK. So here is K2 in a lovely wooded setting in the Berkshire, Hampshire borders. So here we are. So we could plan a trapezoidal metal sheet project here. So I won't go over the parts that are the same for different roofs, but we'll look at what is unique for trapezoidal roofs. So we'd be planning a monopitch roof or a gable roof. Now we want to select the correct one because the wind load zones are different for each type. For a monopitch roof, you have high wind loads along the ridge, whereas they're not there for gable roofs. So it's important that we plan with the correct one. So we'll choose a gable roof, rectangle shape, trapezoidal, and then as with before, we're going to draw on the roof. Now, if you draw along the eaves first, sorry, let's do that again. We draw along the eaves. Then it'll automatically put the slope in the right direction. But again, we can change that if we want to and have the slope where we think it should be. Now, one question that comes up sometimes is, should you draw over the whole roof like this, which is the northeast face and the southwest face, or should you draw over just the southwest face that you're using? So the correct thing to do is just the roof face that you are using, as we show here. So we will enter our building height, our roof pitch, our roof covering. We've got trapezoidal. Now with trapezoidal roofs, we can fix to the roof covering or the roof construction. We're just going to cover roof covering here because that is what is done 9 times out of 10. So the important parameters we need: the crest or crown distance, as shown here. So a common distance is 333 mil. And the crest width, which is the width of the top part of the crown. Another common one is 31. And then the overall height. Now, the important thing for planning these systems is to know particularly the roof material and the thickness. So perhaps we know what system was installed on the roof and we can find a data sheet, or we need to measure this at a survey with calipers. But generally we might expect a steel sheet with a 0.5 mil thickness. So it's important to know this because we're fixing into the steel sheet with self-tapping screws. So we need to know exactly how strong these screws are going to be on the steel sheet, and the thickness has a fundamental impact on this. Now you can see there's lots of skylights here, so we could draw these on. We could duplicate these. And so on. We enter our module array. Now here you see we have some different options. So our systems for fixing onto trapezoidal sheet metal, we've got mini rail, mini 5, speed rail, multi rail, and our insertion system. So mini rail, speed rail, multi rail, and the insertion system are all roof parallel, whereas mini 5 is elevated. So the mini 5, for those that don't know, is to use the mini rail system and have a 5-degree elevation on the modules. And then generally for roof parallel, you would use multi-rail, mini rail, or speed rail. Multi-rail is a short 10-centimeter rail with 2 screws. Mini rail is about 40 centimeters. It crosses 2 crowns and has 4 screws. And speed rail is continuous rails that fixes to the roof with these black speed clips. So we'll plan a mini rail system. Module orientation, we can choose portrait or landscape, and again, complete roof or module field. So we'll plan a complete roof in portrait. You can see the obstructions mean there's no modules planned around the skylights that we entered. Okay, so mounting system, mini rail, module orientation, portrait. Now perhaps you'd like to see if you can fit more on the roof with portrait or landscape. So portrait, you can see we've got 628 modules. If we try landscape, 627. So perhaps this helps you make the decision of what layout to use, as in how you can fit most on the roof. So again, we have our thermal gap parameters. You see for mini rail, we would want a gap along the row every 18 modules, and you can see that they're shown here. We wouldn't want anything greater than 18 modules, but again, perhaps you would like maintenance walkway after every 10. So we could plan this in same as before. And there we have our maintenance gaps. And now we have 577 modules. So you can see how it constantly changes depending on our parameters. just noticed we're not working in expert mode. Now, we've toggled to expert mode, and there's a useful parameter that pops up, which is minimum roof edge distance. Now you can see here that the modules are planned right up to the roof edges, which is perhaps impractical. So we could change, for example, 1.5 meters, and then we have a nice perimeter around the array. And again, we can check how many modules we have, 436. Something I didn't mention with the S-Dome system is how to change this array if you've planned whole roof. So we can delete individual modules just by selecting the delete function and clicking on the modules. We can also delete whole rows and whole columns. So here I'm holding shift and click and control and click. So that's an easy way to delete multiple modules at once. And perhaps we decide that we don't want 7 rows of 70, we want 6 rows of 70. We can click this edit module array outline, and we now are able to manually change these figures. Okay, so here's our mini rail array that we've planned with our 1.5 meter minimum distance from the roof edge, modules and portrait. Now distance, modules, short side. This is a level of detail that perhaps you don't need to worry too much about, but everybody has a preference for the distance that they would leave between the modules here where they're not clamped. Some people use a mid clamp as a spacer. Some people just go with what looks good. So you can plan in accordingly, but as a default here, we've got 10 mil. Now calculating loads in the UK, there's currently no automatic function, but we are working on it. So you're referred to the wind load map according to the UK National Annex of the relevant Eurocode. Now, if you're not sure where you are on this map, you can jump back to project and zoom out. You can see where exactly you're planning, or you can refer to Google Earth, for example. So we're within the 21.5 meters per second area. The terrain category here is country or rural, and then you can measure the distance to shoreline on Google Earth, which I think is around 50 kilometers. Next, we need to select our snow load zone according to this map. Now here, perhaps we're in area 2, perhaps we're in area 3, so we could err on the side of caution. Go with snow load zone 3. And now we have our peak velocity pressure and our snow load on roof. So we have the loads that we are planning for. We select results. And here is our mini rail system planned. So these are the mini rails. Now if we show the roof structure, you can see each rail is fixed to 2 corresponding crowns. Here we have the fastener. There's only one option with the mini rail, there's nothing else to choose, but this is what it is. So you're fixing to the sheet with a 6 by 25 mil screw, and the rail is the mini rail. And again, we have the options for module earthing with TerraGriff and cable management. So we can check the loads on modules again to see whether they are within the limits set by the module manufacturer. And we can check the system utilization. So we can see here the fastener is at 97.98, which is below 100%, which is great. everything else is below 100%. So the selected mounting system can be installed as planned. We can see also, so up here on the top right, we can select which layers that we view in this screen. So we've got base rails, fastener, roof structure, and obstructions selected. We can take any out and put them back in. But roof zones is quite useful to see. Now the roof zones are split according to Eurocode, and they refer to the impact of the wind loads on the different areas of the roof. So the grey central area is what we call the field area, where the loads are the least. And then we have yellow areas at the eaves and at the gable board, where the loads are much higher. And then we have the areas in red, which are in the corners, where it's a combination of the eaves and the gable board, where the wind loads are at their greatest. Now, if the utilization was over 100%, then we would expect to find that the modules are sitting in these areas. So we can turn on that view to see where the problems are and then redesign the array accordingly. And then again, we have our summary. So we have the roof that we've planned, we have our bill of materials, we can produce our project report and our various output documents. Now, if you're going to send your bill of material to a distributor, it's important to know that this bill of materials is exactly what is required. There's no spares allowed for in there. So if you wanted to, you could edit your bill of materials, change your figures manually like this. And this would apply to the documents that you output to then send to your distributor or to your K2 representative. Okay, so we've planned a flat roof system and a trapezoidal roof system, which are probably the two most common roof types. Now we've had a steady stream of questions, but we'll allow a few more minutes now just in case anyone has got any more, or if anyone would like to see anything in particular demonstrated on the software. So feel free to type in a question or to raise your hand. I'll just give you a few minutes here. And of course, if you don't have the opportunity to answer a question today, or to ask a question, sorry, or if something comes up that you later think about, then feel free to send us an email. If you email info@k2-systems.uk.com, then that will reach the team here at K2 UK, and we can have a look at whatever queries you might have. Okay, well, there's no raised hands, no new questions. So I think we'll leave it there. Oh wait, a couple have popped through actually. Okay. Okay, yeah, a question there from Ulf that I'll answer here. So we touched on it briefly, but perhaps not with enough time. So this distance module short side, this is the gap between the modules in the column. So it's not a gap where a module clamp is, but you might like to leave a larger gap for heat dissipation or for aesthetics or anything. So here you just change this. Sorry, I've changed the wrong parameter there. Distance module short side. You change this, and that will change this distance between the modules depending on what you'd prefer it to be. As default, it's set to 10, so there is a gap. And I think you'll see that our minimum is 5 mil, which I presume is a recommendation of module manufacturers. But yeah, whatever you want it to be, you can put it in there. Michael, a question about the bill of materials. If you enter a value lower, does it go red? Good question. Let's see. I don't think so. No, it's still green. So anything that's altered is highlighted in green. And then you'll get this message flag up on everything that you do to remind you that there's been a manual alteration. So yeah, there's no color coding for good or bad. It's just color coding to show that there's been an alteration. Okay, what else have we got? Joseph, there's a module which is not in the list. Okay, well, for now, you would just need to enter your details manually by clicking user defined and putting them in here. I mean, you can even type in BYD so it appears nicely in the report. But we can look at getting that added into the database. I don't know exactly how we do that, but I'm pretty sure it's possible. So we'll make a note of that and see if we can get that one added to the database for you. So the BYD PHK-30-280-5BB. Okay, and there's a question from Dio about high wind speeds. Let me just find your question. Where's your question? Okay, what is the maximum wind power that can be inputted, and what about the storm? Okay, so depending on the country that you've selected and the design method that comes up, you're working according to the relevant Euro code, which is a very simplified version of all of the parameters that they have to safely calculate your system. So here we only enter a basic wind speed according to this map, but the Euro code does allow for high wind gusts and storms that are within expected limits. But everything in here is according to the Euro code rather than anything in particular. But I mean, the Euro code is a long, detailed technical document, but there is provision in there for storms and for wind gusts. So generally speaking, by using the correct basic wind speed here, you can have confidence that storms are accounted for. There is an argument that storms are getting worse with climate change, and I believe Euro codes are being looked at and revised in accordance with this. But at the moment, we work with all the current Euro codes, so we work with the relevant standards and input parameters. But there's nothing wrong with using a higher basic wind speed if you feel it's necessary. For example, we did a project recently for a customer in Dover, which is somewhere down here, right on the coast, where the sea was facing sort of three sides of the array. Now we could have used the wind load that Euro code gives us here, which is, you know, whatever, 22.7, but we planned for, I think, a basic wind speed of 27 meters per second, just for that added security. The request came originally from, I think, a structural engineer who said you should plan according to a higher wind load. So that can be done. You basically enter whichever value you like here. Certainly don't enter anything lower, but if you want to enter something higher, that's fine. You can also increase the safety factors by working to a higher failure consequence class. So CC1, consequence class 1, is selected as default. If we select consequence class 2, then safety factors are increased. So the effects of wind and storm and everything are increased, and we demand then more of the structural capacity and the fixation strength of the system. So if you know that your project location is particularly exposed and the wind conditions are higher than you think the Eurocode says, then you simply enter a higher wind speed or increase the consequence class. Or certainly, when you're then referring to your system verification, which here is high now, but before we had, say, 99%, then perhaps you say, okay, I don't want to plan for 99%, I'd like to keep it below 80% or something. There's different ways to factor that in, but generally speaking, the Eurocode wind load data allows for storms and allows for gust speeds, so you can have confidence in these in this data. So Dio, I hope that answered your question. I hope I'm pronouncing your name correctly. There's a few others popping in. Let's have a look. Yusuf from Indonesia. Oh, that's been answered. Yeah, no, I think we've covered everything. I'm sorry if we've missed any questions. But again, if there's something you certainly haven't missed the chance to answer to ask the question, send us an email. The email you'll find on our website, but again, to contact us in the UK office, it is info@k2-systems.uk.com, and we'll be happy to get back to you. Alrighty, well, thank you very much, everybody. It's great to see so many people here, so many questions being asked, and such good participation. We do appreciate it. I hope it has been useful for you. We'll close the webinar for now. You'll soon find this one and all our other webinars on our YouTube channel, and the YouTube channel is definitely worth looking at because we've got lots of product demos on there. So I do recommend having a look at that, and I wish you all a very nice rest of the day. Okay, thank you very much. Bye-bye.